Why, hello there. Make sure everything is squared away here. Oh, we don't have game audio. Don't think. Wait. Now we do. I don't know how loud it is, though. Y'all will have to tell me. Turn it down just a little bit there. Better too quiet than too loud, I think. Yeah, today we're going to play some games. See how it goes. Have some fun. As soon as I make sure that everything is happy and that I can see all of that. Hey Marco, how's it going? Need to make room for chat. See here, unusual time for a manga stream. Yes, I know. Played this back in the day. It's super fun. Yeah, I played a little bit of it a long time ago, like probably last year, I think. Hope you enjoy Assembly because this is reminiscent of that. Yes, I've played more Exopunks than I have Shenzhen, or however you pronounce that. And it's definitely different. Oh, gotcha. I was confusing you with the other Marco there. How have you been? How has things? How is all of the everything? Alright, let's see what we got here. I got the manual open. I guess I could try to put that on screen too, but I don't know where I'd put it. Maybe we'll just rock and roll without it for meow. Maybe I'll put these down here. Alright. So. I believe we have to open yes. We have to read our email. Writing the last chapter of my book. It is 158k words, so around 160 should see it done. Nice. Start looking for publishers around here to see if any would like to pick it up. That's pretty rad. Have I been? I've been. Work is definitely work. And it has really slowed down the channel, which I'm not super thrilled about, but, you know, not starving is good. So, there's that. Will you be doing the Advent of Code this year, presuming it is still on? You know, I actually hadn't thought about it. I don't know. I'll have to give that some thought. I don't think I've ever actually done Advent of Code before. Tried Starvation once when I was young. There's no future in it, right? Alright, so we are a new employee at this electronics company. Doing Advent of Code in Rust this year, just out of fun. My coding Padawan will likely mimic me in Python. You could bring in Go, so we have the unholy trinity. I suppose I could. I would have to look at what they're actually doing. Because if it's just like... If it's just CS puzzles, I'm really not interested in it. Okay. Let's see here. Connections. Okay. It's just like a mini story as a framing device for CS puzzles, and the puzzle's usually quite innovative. Gotcha. How long do they usually take to do? This is a very strange email application. It looks more like it's a thread, but like people are just chiming in like a Slack, like it's Slack. Okay. Okay. Speed coders usually get each day's the puzzle done in a matter of minutes, but for experienced coders, I think 30 to 60 minutes is somewhat average. Gotcha. Because I've only got, you know, like 2 hours, decent hours a day before I start to get pretty sleepy. Long days. Okay. Carl says to read the manual. Listen to Carl. Imitation mock security camera with 2 blinking lights. I figure I'll have plenty of time to sleep when dead. It's getting back up the next morning, that's the trouble. Let's see here. 2 blinking lights. First light blinks in a regular pattern. Second light is an internet light, so it should be blinking in a more random intermittent pattern. Resemble data upload. It's a mock security camera. Okay. Design is partially complete already. A previous engineer quit before finishing the assignment. Note the timing diagrams in the verification tab. When you simulate, your output should match those expected values as indicated. Let the simulation run until it's passed all the test cases to make sure you have a proper solution. Okay. Let's see what we got here. Oh, I've already created a duplicate. Open this one. Where was the verification? Okay. I remember there was something to do with like time blocks in here. Move 0 to P0. Okay, so he sends power, sleeps for 6. Move 100 to P0, sleeps for 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this is probably the correct. Yeah, this is correct up here. Why is this so hard? Okay. We're going to get rid of this defeatism here. We don't need any of that. And we only have this guy. So we're going to... They say random, but this is very much not random. This is regular. So 1, 2, 3, 4... And I'm assuming that's turning it off. Oh, part not sleeping. I remember something about that. We're sleeping for 4. And then 100 to P0 for, I guess, 100% power or something. Is there a... Let's see here. There's emails in the manual. I want that. Like, we could just figure this out, but I would like... Yeah, on 100. Think of it like a game of D&D. Time only advances when everyone is sleeping. It's not true. It's not true at all. So we sleep for 4. Then we turn it on for 2. We move 0 in there. Sleep for 1. And we loop around. Easy peasy. Simulate all of them. Do all of the simulations. Perfect. Piece of cake. 6 whole yen worth of cost. Interesting. People have done this in like 1 line of code? Okay. I'm not going to fall down the trap of the, let's see here. Oh yeah. I'm not going to fall down the trap of the, optimizing everything for a high score. We'll be here all day. Okay, let's see here. Mailing list for expats. Cool. Okay, it's very philosophical there. Smashed. No need to worry. Okay. That doesn't sound ominous. We're adjusting some kind of signal here. Roll in is a simple input. Control out is a simple output. Control in should be multiplied by 2 and copied. Okay. That shouldn't be hard to do at all. Doop. Oh, those can't go. It needs to be there. And this is a signal. Tell me more. Tell me more, Emmanuel. I/O pin. Where's the diagram for this thing? Oh, here we go. Okay. Simple I/O. 0 to 100. Okay. X bus. X is data packets. Okay, I see. Simple I/O can be read or written at any time with no regard for the state of the connected devices. X bus is a synchronized protocol. Data over X bus pins is only transferred when there is both a reader attempting to read and a writer attempting to write. Okay, cool. It'll block. It's a blocking. I summarized that email as, yay capitalism, but why though? I mean, kinda, yeah. Okay, so. And they're showing you can chain 2 of these guys together and use the X bus to do things in the manual. But we don't need to do that. We have this in, and we just need to multiply it by 2. And there was a, how did they do multiplication in their little language here? MUL. So. And how do I... Can I do this in one line? Or do I need to put you somewhere? Can I say... Can I do that? Too many operands. Okay, so I can't. So what I need to do... Can I... Where's my other reference stuff here? Can I move... like that? No. What was the correct syntax for that? See, they've shown examples of that. Do I just mull? ACK is the primary general purpose register used for internal computation. Right, I remember that now. All arithmetic operators implicitly use the and modify the value of ACK. Okay, so I just need to mull 2. And then 2 P1. And then sleep 1. Right? Perfect. I recall mull 2, the ACK is implied. Yes, as his destination. Yep. 3 yen worth of glory. Oh, did we have follow-up emails here I didn't read? Oh yeah, just, it looks okay. All right, cool. Yeah, it is implied. I completely do not remember the syntax to this game at all. So we're learning again. It's fun. All right, please enjoy a game. We have to win a game of solitaire. All right, we're going to do it. We're going to win some solitaire. Okay. 1 to 9. Stacked and moved into the center. Alternating suits and decreasing values. Resales for anything. And then when we're... all 4 dragons... permanently move to an open freestyle by pushing the corresponding button. I remember liking this game, actually. But I don't remember... I think this is 1. No, it's not. What are you? Are you the king? You must be. You must be the final. Alright, let's see. We need to dig out another 1 here, probably. I guess we'll put you here. What the heck are you? I don't remember you. Are you the cap for the black suits? Have questions. Or are you a 1? No? You're definitely not. Okay. See what else we can dig out here. We have a 2 for that guy. Ah, okay, yes. This is the cap of the suit. The dragon, that was what they were calling it. Where do we have our 2s buried in there? My other 1 is there. Why do I have 2 of you? I don't remember what these cards mean. Let's dig this guy out. What are you? You're the top. For this. I wish it wouldn't automatically do that. I would have liked to see if I could put you on there. May have just screwed myself with that. That didn't automatically move though, which is weird. Let's restart. Okay. And I can't put you under there because you're top card of some kind. I wish it told us where they fit in. Oh, all 4 dragons. Okay, so there's 4 of... I see. Okay. I got to read all of the screen. That would help. So if you put you here, we can dig out our roses. Can these guys stack? No. We dig this out. That'll free up that. We need to dig to the bottom of this one. There's a 3 in there, but that doesn't get us much. This is all high level, high face cards. There's a 4 in there with nowhere to put him if we dig him out. We would have to do... I think this one is not so. I think I'm leaning towards agreeing with you. This one, that's a good start. Let's see here. Got another 1 there that I can free up without using a free slot. There's a 1 there. That's the roses, though. Wait a minute. What the heck is the rose? He just hangs out up there, I guess. 5 is there, our 2 is there. Our 3 is buried, though. 2 is pretty well buried, too. We put all 3 of these up here. You could come over here. Then there's nowhere else to go from there. Don't recall if you free a whole column, can you put whatever into it? I don't recall either. That's an interesting question. I think the main problem is the dragons. I don't think you can put them anywhere. Move red sword in the middle. Move 6 on a 7. Can you put red sword back in empty? Good question. Let's find out. I can. I can. But these guys don't stack, which is not ideal, but you know. You can pull him out and get a 5. Do we leave him there or stack him? Available 6, you can do the same on the other side, yeah. 4 can come down there, which would leave 2 over there. That 2 is pretty buried. Put him here. Get this out here. Put him there, I can get 6 out. That gets me a 9, which isn't terribly helpful. I really need to get that 2 out of there. This is rocket science to me. Marco! It is Marco! It has been a while. That's why I'm trying to be able to get on more during the day on my days off so that I can hang out with all my friends. You get my 3. I could get another 4. Then I'm kind of stuck with my freeze all filled. Gets me another sword out. It's a good name for that one. I like that name. They weren't joking when they said it's not easy, right? I remember this having like a pretty decent learning curve to it, but eventually, as you play more of it, you kind of get the feel for it. I remember liking it a lot. Which was surprising to me, because I'm not really a huge like solitaire guy, but you know. If I put you here, I can put you here. Then I would need an 8. Which I don't have access to. I would need a home for you. Put a sword up here. I don't know if I can stack these guys when they're not... Let's see. Stash another sword and pull the 9 stack out. Then you can get rid of a few more green cards in ascending order. Right. When do you start writing lifetimes on the cards? Right. I don't know if I can stack. Let's find out. These might have to be... I can't. I can't pull that stack. Dang it. Okay. But I could do this, this, this. Then I'm kind of stuck. Except for I could go here. Can I just drop you? Ooh, do I want to drop you? I could do this. What I can do. That gets you up there. Or 5 gives me a spot. That gets me a 5. Then I need to put 6 somewhere. You're blocked in there. The other 9 stack on the right. I think that message was before I move things. Let's see here. So I can't... Oh, wait. I can move this stack. Okay, so you can move a stack if it is in order going down. Seems to be the rule. But then I don't have a home for him. Can reshuffle sufficiently to put away the blacks up to 7. Yeah, but I'm trying not to shoot myself in the foot by doing that. It's my concern. But then I guess, okay. If you go here, I need that 6 to find a home. Which can go here, like so. That. Ooh, I think I just misplayed there. I think that just killed me. Yep, I just screwed myself. Not sure if there's something else, but it was definitely a hasty move. Yep. Mm-hmm. We go again. Alright, let's see what we can do. I want to really try to put off putting things up here as long as possible. I say before immediately thinking, I need to move this one out. Third time's a charm, right? These dragons that don't stack are kind of the wrinkle, right? I'm going to put you here. I might regret that, but I'm going to do it. You're more likely to be able to come out sooner, so I'm going to put you there. Gets me here, gets me here, gets me that, which gets me a space. Do I want to do that? I want to dig into there. Which I can start doing here. If I move you here, I can move... No, I can't. You're not out yet. You're at 2. Start with the green 9, you can clear the column. Yes, I see it. Green 9 down, put green dragon up, shuffle until uncover the last sword. Green 9 down, green dragon up. Yeah, maybe. I can also put green dragon up, pull green 9 down. 8 comes over here, that frees me up. Yeah. 9. 8 comes over, 1 goes up. Oh! They don't have to go up here. Oh! Things have been learned. Eat up a space but clear away for a card, so it's good, I guess? Yes. Yes. If I go you here, I don't have a place to put the 5. Where did you learn to play for this? Just now from watching, right? Same. You can go here. That gets that up there. My 4 is kind of in the way, but it doesn't need to be. That gets me another space, which is very good. I like it. Where's my 2? You're in here. I can move you here, move this here. That'll get that out of the way and organized. I guess I can move one of these here. Need... Marco with the Apple loading bar going on there. Let's see here. Move green 8 to red 9. I think I did exactly what you're talking about. Yep. I need my 2 to come out. That'll start unblocking this. I move that here. I have one more space to play with. This 3 could go up. Yeah. 3 can go up. 2 can go over. Perfect. Now, because you're not unstacked. Ooh. 5. You. Oh no! I misread that. Oh, I've got cards here that can go away. 9, 8, 9, 8, 7, 6. 6, 5. Gets those up there. That was very satisfying. If I move you here, yes, perfect. You here, you here. I win! We've completed a goal. And we even got a Steam achievement to win Solitaire. Perfect. Let's see, now clear red 5 and 6, and then get rid of green dragons. Yes, yes! Great minds and all. Exactly. Let's see here. Okay, well, I don't know what any of that says, but we'll go with it. Let's see, I done thunked up a new good joke today, by the way. We'll share with the class. What's your good joke? Oh, we got more parts now. Good. Pulse generator with certain requirements, specifications. However, instead of buying one to market price, I thought we could simply create our own. That's how they get you. What are the most commonly told lies in the modern world? Commonly told lies in the modern world. I don't know. I'll fix it later. That shouldn't be too hard. I've read and accepted TOS EULA 2. We value your privacy. I thought you said this was a joke, not a statement of facts. Okay. Conditional execution. Please continue your study of the language reference. Okay. What do we got? Button is a simple input connected to a button. Okay. Pulse is a simple output connected to an electrical device or electronic device. It's satire. Well, it just made me sad. Part not recommended. Okay. When the button is pushed, generate pulses as indicated in the verification tab until the button is released. So it's an on, off, on, off. Okay. And then... basically, it's just a regular pulse, but only if the button is held down. Remember, kids, just a few hours of trial and error can save you minutes of reading the manual. I'm in this this statement, and I don't like it. So I need to learn what the if... Okay, so there's a loop. I don't know that we need to use a loop just yet. Because it obviously loops if you don't put a loop in there. And is there an example where... yeah, we just need to test if it's equal. Oh yeah, now we're talking 1, 0 and conditionals, right? So we do that, right? At the start. If it is, and I think that's a plus. Where are you, manual that covers that? Conditional execution, yes. Prefixing an instruction with a plus or minus symbol will cause that instruction to be enabled or disabled by test instructions. Okay, so if it is, I think we want to start that. Maybe. Or do we... can we get away with doing it this way? If it is, move 100 there. If it's not, we move 0 there. And then sleep for 1. And then we do it again. Which means we just do that. Except we have to do that. I think I'm missing something. Yeah, I'm off. Off by oh, because you don't ever... yeah. We never move it to 0 if the button is not Is there a way to put you into... I guess we could just... Maybe we do use a loop here. And we say, at the start, we move 0 there. And then we go into our loop. Or do we even need to do that? What if we get rid of that? We test if you're equal. If you are, we move 100. If not, we can go to end, which is we move 0 there. Up here, we need to sleep for 1. I don't know if my control flow is correct. No, because it moves to 0 down here. Maybe. We move 100, we sleep, we move 0. Why didn't it move 0? Oh, because okay. Duh. Because the button is held down, it's going to be always. So. We need to do one evaluation cycle here, essentially, right? Where we say, if the button is pressed down, we move 100 there. We're going to put this into a loop. So we say, instead of this, it is, we're going to jump into there, right? Otherwise, I'm going to jump to end, remove 0 in. Or not 100, 0 to P1. Oh, that's as big. Okay, that's as big as I can be. I see. That's as many lines as it fits in here. I remember that now. So here, that won't work either because we don't have enough room for you. We need to sleep for 1 in here. I think we can get it out with actually just that. If you're equal at the time we check, we enter a loop. It's not not marked as a loop, but it becomes a loop where we just send a pulse and then we can reevaluate. I was overcomplicating things, I think. Let's see if I missed something. Oh, I'm off by 1. Why am I off by 1? Oh, because I sleep twice, that's why. Can I put all of these into... except for the last one? I can't. Okay. There we go. Simulate it up. Brilliant. Loves it. Something slid. Let's see here. Looks okay. Suitable for our purpose. Thanks, boss. Don't break your arm patting me on the back. Well, this must be slightly in the future then, because we have space tourism. International superstar cool dad. I like it, very satisfying, right? Oh, thank you, thank you. Nicely solved, thank you, sir. Incredible deal with a major esports personality. The Solid Steel Gamer. Her team's contract with us makes light up signs that actually animate for her fans. As long as we can keep the cost down, they're going to want tons of these to hand out at matches. Looks simple, just a few states. Okay. Click 0 and click 1 are simple outputs connected to display segments corresponding to a clicking animation. Drink 0, drink 1, and drink 2 are simple outputs connected to display segments corresponding to a drinking animation. Control the display segments with fixed repeating signals as indicated in the verification tabs. Okay, so... what are we trying to do here? These are all opposite. So this is on, this is off. This is on, this is off. What's my condition here? Oh, I'm not trying to drive this off of... I'm just sending pulses. Okay. I see. So we need... something like this. That's a hideous wire. Probably don't need you to be quite so tall up there. Come on. There we go. So this is just click 0 gets it first. I did that. No. There we go. Right? No. Both then we switch, and then, yeah, there we go. Perfect. Okay, that takes care of our click. And you can see her finger clicking there over on the right. Super cool. And then, see, this needs to be like the same thing almost. Except drink 0 and drink 1, right? We might be able to combine some of these logics. Let's go with this first. So drink 0. And drink 1. How can we combine these? Do I have some kind of a... No. I can use logic gates here, I think. It'd be doable with fewer CPUs, but only with some of the advanced components, I think. Yeah, otherwise you need 3 CPUs if you stick to recommended. Yeah, I was just looking at these guys here. In the spirit of sticking to what they're suggesting here, let's not mess with that just yet. But we might still be able to do something here. No, we don't have enough outputs to do that. What is state in here? Where's my... component instructions here? Parts data sheets. Here we go. Accumulator. Maybe state isn't something I'm allowed to play with. Oh, okay. State actually shows me the state. So state, sleep, state executing, executing, sleeping, executing. I see. Okay. So state isn't for me. It seems tremendously wasteful to do this, but you know. It's 3 yen. That's like what? 3 cents? Let's put you up here. So you move 100 to P1, 2, 3, 4, 5, 6. Turn it off. 1, 2, 3, 4. And that should take care of this guy. Perfect. Okay, last one we'll put here. Drink 1, drink 2. Because this one we can combine, kind of, I think. So let's do you in order just because. Like so. And then 1, 2, 3, 4, 5, 6. Remove 100 to P0. Sleep for 1. Move 0 to P0. Move 100 P1. Ooh, I'm gonna run out of. I ran out of lines here. Sleep for 2. Lines is going to be what kills me here. 0 to P0, 0 to P1, sleep for 6, 100 to P0, sleep for 1, 0 to P0, 100 to P1, sleep for 2. Yeah, I won't have enough lines. Unless I do... I can't do this, can I? Nope. How else can I combine you? I could do... If we gave you another power pin... I think I can combine these two, actually. There might just be enough lines, because I don't have to toggle back and forth quite as much. So these two, move 100, sleep for 6, move 0 to P1, P, this is actually P0 now, 100 to P1, sleep for 1, 0 to P1, sleep for 1, Ooh, I'm gonna run out of lines here too. Gonna run out of lines here too. Okay. Let's back that up. You could combine drink 0 and drink 2. Drink 0 and drink 2. Maybe. Let's give that a try. How am I going to route you to? I don't think I can cross lines. Get you over here. Oh, you're right. I do have bridges. Need to... How do I rotate you? Maybe I can't rotate you. Don't think I can rotate. Okay. Fine then. Be that way. Vertical only move chips, right? Yeah. Behold the violence inherent in the system. Oh, I need to move you. Make all of my... Then I can do that. There we go. Okay. So you're on, and P0, 0 to P1. Sleep for 6. Move 0 to P1. Sleep 1. Move 100. P1. This should be 0. Sleep 2, move 0, P1. Sleep 1. Perfect. And then I just got to do the first move 0, P1 should go down to the bottom, I think. No, because it starts, because it's drink 2, it starts at 0. You start at 100. Yeah. You could, it wouldn't really matter, I don't think. Because we sleep for 1 after we turn you off, and then you turn on. Yeah. You go to 0. In which case you can omit the first ever move 0, I think. You might be right. We can certainly test it. Oh, I forgot to sleep you. You're right. Yep. All right. We sleep for 1, 2, 4, 5, 6. 100 to 0. Sleep for 1. 0. P0. Sleep for 1. 100. P0. Sleep for 1. Oop, this is 2, not 1. Help me fill in these blanks. Premature optimization is the best of all ideas. Right? Is that the one? Is that how it goes? I'm pretty sure that we could go back and use... I remember there being XOR gates and stuff. I don't know if that's how you pronounce that out loud. Exactly, I had the same words in mind. Amazing. Okay, let's see here. End result looks great. Love the way it looks. Like the solid state game is really clicking the mouse button for your soda. Okay. Bring out the Baron. Baron von Schnaps. Love it. I don't remember the actual rules. That's going to make it hard to design something. Okay, point and foul are simple inputs connected to buttons. Methinks Joe might be easily amused, right? Well, I mean... he was out drinking last night, so, you know. He didn't say how much, though. I was thinking he might have said something about the amount. The amount must be high because he doesn't remember the rules to the game. Point and foul are simple inputs connected to buttons. Okay. Display is an X bus display output corresponding to a numeric LCD screen. Counter should keep track of a count starting at 0 and ensure the display is always showing the current value. When point is pushed, the count should be incremented by 1. When foul is pushed, the count should be decremented by 2, but not below 0. Can we get it done in this? You. Simple inputs, right? Just on and off. Yeah. Yeah. So. If this is equal to 100, what is my addition? It's funny that we've done multiplication before addition. Add. It's just add. Just add 1. Then, if it's, that's fine. P0, 100, sub 2. Move it like so. Oh, I forgot to sleep. So. Do you not... Foul input was there. Wait a minute. What have I done wrong here? It should be clamped to 0 on the downward 2 more. Oh. Yep, you're right. Not below 0. I don't think there is a clamp. Wrong place. Down here. After sub, yeah. Well, after the test equal. Because we can test greater than. Oop, maybe not. Let's step it. This introduces a subtle bug. I wonder if tests will catch it. We'll find out. You're not 100 yet. 0 goes out. Okay, that's fine. Now you are. Are you greater than 2? No. Ah. It looks like we can't nest. Oh, I did that backwards. It should be, let's see here. What more than one subtle bug, order of test greater than. I think you're checking 2 greater than, yes. This should actually be greater than 1. Because I don't have... I could test equal, but I don't want to. So if I come in here... Greater than 1. Then I sub 2. But it did sub 2, even though the accumulator was not greater than 1. No, I'm thinking test greater than accumulator 2. Oh. Maybe. Let's find out. Here we go. Aha. Yep, you're right. Okay. And then we do it again and nothing happens. Adds 1, adds 1, adds another. Where's my foul? There, perfect. Now you're down to the original subtle bug. Well, I failed some tests, so... test of 2. How do I go to test 2? Do I have to just manually go through here? That kind of sucks. I remember the UI for Exapunks being better. Okay, so we've got 1. Ah. Because it's allowed to subtract. I see what you're saying. So in order to do this in less instructions, we do this, and then if it is not greater than 0, then you just move in, not 2, 0. What did I mess up now? Oh, I didn't, put you in there. You're 100. Subtract 2. I flipped that again, didn't I? Nope. Nesting that doesn't seem to work. This opens some crazy weird possibilities. The negative move then applies either the first test equal or second test equal based on whether the first... Yeah, right. So. Oop. That still goes in there. Not 11. 1. Okay. So. Go back to this. What can we do? What language features do we have here? Just need to always test for less than 0, reset to 0, maybe. But can we do anything cool? Can move, we can jump, we can sleep, we can... Oh, sleep until data is available. Okay. We can do... digit. To isolate the specified digit, we can set the specified digit. Okay, interesting. We can test compare. I don't think that... So if A is great... With test compare, if A is greater than B, then plus is enabled, minus is disabled. If A is equal to B, they're both disabled. And if A is less than B, plus is disabled, minus is enabled. Yeah, I think we do just have to check always. So if this is then sub 2, and then if you're 0, and I want to do this in the correct order, where did you go? Here you are. Test if the value... Test the value of the first operand is less than the value of the second operand. So that should be that. If it is, move 0 into accumulator. But you didn't work. Sub 2, you're 0. Wrong operand order again, I think. Yeah. Oh, duh. Yeah. First is less than 0. Or less than the second. Do. All right. Bye then, see you in the next life. Ah, how do you say this word? Shenzhen. There you go. Ah, it is not yen. It's yuan. Yuan. Well, I'm glad that they cleared that up for us. No one has done it. Fewer lines of codes. Are you sure? Hang on. I think we just have to simulate again to see the results. Oh, you're right. Yeah. They've done less power, though. They probably had to compromise on lines of code or something. Shows you graphs on the puzzle select page. Oh. Oh, you're right. Duh. Well, there you go. They've also not managed to do it cheaper. I wonder how they did less power without less code, or lines of code. It must cost power to write the accumulator, maybe. It also compares you with Steam friends, if any had played. And here's where I would show my comparison with my Steam friends, if I had any. Shenzhen J saying stuff better. All right. BH, you can also disable that function so as not to leak your stream friend names on stream, which is a nice move by the devs. Can I? I don't know. I'm not going to open the control panel just yet. Just in case there's anything in there. There probably isn't, but you know. Okay, so set advert on your desk, pile of papers marked supplemental data, since that seemed most appropriate. Still have to do this, as sad as it is. Work and all, even if you have to help a dodgy American company market rubbish like this as premium kit for audio files. Wrecked. Is it in my... Nope, it's not there. Where's my... That must be in here. Supplemental data section. Ah, okay. Supplemental data. Let's see. Denver Timekeeping. The Logic Company. Where is... Sound Module Blaster, maybe? This part is for prototyping only, they say. Ah, now here it is. Harmonic maximization. Sunnyvale Institute for Audio Engineering. Let's see here. Audio out equals audio in minus 50 times 4 plus 50. Okay. Okay, that's all they tell me. Alright, so audio in is a simple input connected to an audio source. Audio out is a simple output connected to an audio receiver. Maximize is a simple input connected to a switch. So I have to use this one because... Ew, except for that only has 2. I can't do that. This algorithm is somewhat more advanced and innovative than modern-day AI startups. You're not wrong. This has more X's, but not more P's. So that's not good. I would need to... Why this when the switch is on? So we need you to do this. Like that. In Star Trek Scotty's voice, we need more P. I cannot do it for a captain. I need more P. So we're gonna need to do like another one. With a P and then an X. That one was flawless. It's all right. I give it like a 6. I hope someone on Twitch clips it. I don't think this game is very big on Twitch. So I need to look up reading the X up here in my handy dandy manual. Manuel. Right? Or is there a better, more cleverer way? Might be time to bust out the old Factorio one of these days. Are you getting Factorio withdrawals from these little wire traces? I guess we could do... Says you're not recommended, but that's all X's. I can't even really see what they are with that thing in the way. Yeah, actually, were it not for this stream, which I'm contractually obligated to watch, I would have been playing Factorio this evening. I mean, you could play Factorio and watch if you had a second monitor. This seems just a horrible way to go about this. Because Xbus is blocking. So I would have to... this, and I have to make up my own data packets. I can just do a 1, otherwise a 0, sleep for 1, and then over here I would have to say that if you're greater than 0, then I'd have to do before that P0 to the accumulator. It's MOV. And then if you're greater, then let's see here. I have one of those ultra extra wide monitors so I can do both on the same one, but then I wouldn't be paying so much attention to this and missed out on all the experimentation fun. I mean, that's true. That's true. I guess it depends on how plugged into the factorial you would get. So if this is true, I see where the wrinkle is in this puzzle. I bet you can't, you have to do all the math manually. You can't just write an equation, which is what they've done, which is down here. But that's okay. We can totally do this. Parenthesis first. It's sub 50, and then mul 4, and then it's add 50. Move that to P1, sleep for 1. See if I messed up. Did somewhere. Goes to here. There. You're not greater than 0. So we keep sending zeros. Oops, I went too far. Here. P0 should be 100 right now. Why aren't you an 100? I'm mid-design for space platform and also prepping expedition to another planet, so I'd have to focus extremely hard on that. Gotcha. Operand order? I don't... Yeah. I don't know why I can't seem to get that right. Still not quite right. 1 goes here. Oh, because I've done it wrong in both places. That's why. There we go. Same thing on right chip. Yep. Somebody managed to do that for way cheaper. 2 whole yuan cheaper. Wow, I'm high on the power too. Interesting. I wonder what they were doing to get so much lower on lines of code. Let's take a look. Just a quick peek. They probably did fancy math. But it's not just times 4. It's minus 50 first, times 4 plus 50. There's probably some math trick to that. That reminds me of another joke. How many Spanish-speaking people does it take to change a light bulb? Just one? Or Juan? I don't speak Spanish. I'm not sure the correct pronunciation. I'm just gonna let that ride. Yep. This thing is awesome. I hooked one of these babies up to my stereo at home and it blew the speakers clear off. Seems a little suboptimal to me. Rogue loop incident. In this world, the self-driving cars are powered by fuel of some kind. Infrared sensor. Acid monitoring station to detect illegal activities, carbon emissions, growing operations, immigration. If it gets the law and generates heat, we'll detect it. Okay. Let's take a look. In this world, the self-driving cars are apparently all Teslas. In this world? Because they refuel themselves, so that's not Tesla-y. And I don't think Waymos aren't Tesla-based, right? There was another one too, I thought. Okay. Time is a simple input connected to a DT2415 clock. Must be this guy? Oh, hey, I can rotate him. That's cool. You seen that pipe dream of Automagic swapping battery pack? Not really, but I don't really keep up on the Tesla news. Is there a don't see a... Nope, nothing for the clock and the supplemental data. Where is my components? Microcontroller, IO expander. Oh! I don't think that would have fixed our last one. It was some years ago, yet another of those, we can do this next month, yada yada, grab investor money, then never materialize. Gotcha. Okay, where's my... Hey, there's a RAM chip in here. Cool. And ROM. Logic gate, timekeeping, here we go. Incremental clock. Corresponds to the number of 15-minute increments since midnight. Okay. Current time equals the on time the device should be armed. Alright, we'll start with the small chip and we might have to get bigger. We'll find out. Current time equals the off time the device should be disarmed. Except for these are going to be simple guys. Think. NC. What is NC? Let's see. It doesn't say. I get no connection? I don't know. So it's between 0 and 95. So that comes to our P0. And once again, this guy won't. He doesn't have enough simples to do this. So I think we need 2 controllers here. And does this guy... How does this guy work? Not sure there are. Anything on him. Interesting. What do you do? Can we... I guess we could do... Oh, that's a min... Ooh, okay. If we do this, then we should be able to just examine. Okay, so those just emit a fixed 93 and 38. Okay. Interesting. So can I do... this to get me... Yeah. Okay. So I can read those on the X. That's cool. So maybe I can get away with this. Or maybe not. Because alarm is an output. Well, yeah, no. Sensor is a simple input. Time is a simple input. So I'm going to need to do the same thing here. so for you, we can put that there. We need you to come out here, though, a little bit. Because we need to bridge X0, X1. No, but then I can't. I don't have enough X outputs. What do they call them? X bus. I don't have enough X buses. I need this guy instead. And he can take this on the simple. Oh, I can't do that really. That. Those are inconveniently placed. How about this? We'll make them nice and pretty. Except for I don't want that to be here. I want you you have to be vertical to get across. I need this to have some space to come in there. Put one there. And then one here. Except I can't. Unless I do that. I can't do that either. Need you to scooch a little bit more still. Still a little more. That. And then you, and then you, and then you, and then you, and then you. That looks about right. Okay, so here we say X0 P1. If P1 is greater than X0, we'll just do 1 and 0 again for our data bus to our own piece. So we move you to X2. And then, well, hang on. Can I do that? Or is that? That might be flawed. We'll find out. If it's greater than 0, and then was the 20. Then we do that. Otherwise, move 0 to you. I don't think I've captured all of the cases here. X0 is greater than 0. And this is greater than 20. We move 100 there. Otherwise, I don't think this is going to fire correctly in both cases. We can find out though. Locked on read. Okay, hang on. Actually, this I think I can do in one. Well, no, I'd have to be 2. But if P1 and X0, then I move 1 there. Well, no. That's going to make my things worse. Because it's going to block. So we moved. I think I've done these backwards again. I have. Oh, I need to... Wait. Can't do this that way. I'd have to do a different representation of the state here. So, hang on. I would need to do... I don't think there's a greater than or equal to. We could possibly do compare here. We can say if A is greater than B, positive is enabled. It's equal to B, they're both disabled. I think what I actually want to do here is greater than. Put you in a loop where you continually send. Can we do this? Good. Okay. So here we move one and then I don't think this is going to get us what we want, though. Because of the funky nesting. P1 is greater than X0. That. But I can't do that. Can I? Move our X in. She's blocked. T is 84. So we would have to do a false there. And then here, that would have needed to fire. And then we're blocked again. What I really want is more, and this is all the X's. I want better outputs is what I want. guess I could eliminate this. And then say that your whole job is x0 is greater than 0. Test greater than. First operand is greater than the value of the second operand. That. You might not even need a sleep because you just get driven. Locked on read. This be a tricky one. The laws of logic be a harsh mistress, right? It's more the laws of the pieces I'm allowed to play with. Okay, there we go. Now I'm back on track in sync because it needs to sleep at the end. Otherwise it is listening before it's ready to send and it won't wait. Okay. And then we get to here. But I also need to, up here, now account for if this is greater than I don't have like and statements and things. Let's check this. I'm not happy with this. Because if it's equal to, it also needs to fire. But if these guys are both okay, so if we can compare X0 and P1. Well, if they're equal, they're both disabled, though. And if on and off get flippied, that's also a bad thing. Can't really see what these parts even are, so I'm gonna try to limit myself to these guys. So here, wraparound on values is often the real pain to deal with. I mean, with such limited things, yes, indeed. That's part of the puzzle, right? It's a very limited language. You have very limited space, and you have to wire things up too, right? That's the fun of it. We have data. What is data or DAT? General purpose data register used for additional on-chip storage. Okay. It's basically an advanced, fancier version of off by one, right? Okay. So like the brute force method is that we just do both, right? Or that we could do a couple of smaller controllers to feed into this guy. And I don't have... greater than or equal. This one I could do. Sleep until that one. Just to be interesting. Except for it's 0. We can do that. That doesn't really get us where we want. We could... okay. If these two are equal... we say armed, right? And then here we can say... 20, right? But this is backwards. 20. If P0 greater than 20, then move 1, X1. Up here, and we could then do back to armed. Up here we can say X1 and P1. But we don't even need to do that, actually. If we just give you that. Think? We need 2 sleeps, though? No, but we need to send. Otherwise, we send you 0. So that you don't get cranky. Block done right, block done right. What? Oh. Because it's X2. Except for now, you're just forever... Why do you... You're not equal. You're 84 and you're 93. Move 0. Okay, yeah, that's correct. Oh, because of that. This one. If it's not, jump to safe. This feels kind of hacky and gross. Oh, because we don't jump to safe because we're still in armed. We actually need to just move 0 because we're no longer alarming. We're still armed, but we're not alarming. I feel like I could have done this in fewer lines, perhaps. Ooh, we missed one. Okay. Test run 3. Close to the end. Right there. What happened there? 40 and 68. Personally, I'd use one of the chips exclusively to decide whether we're safe to arm the other compared to the arm value. Yes, yeah. Could distribute a code a bit more evenly. Yeah. That did absolutely occur to me. But I was trying to get it done with fewer parts. But this has bitten me. I wish I could go back in the test. This is a very bad UI for that. I need to go to 3. And it was down here, perhaps. And it's because jump to armed, X1, P1. It's not. Still not. It's down here, right? Still not. $58 is still less than 68. Oh. Because we can only check equality or greater than. Sunk cost, right? Place a breakpoint before the breakage. Oh, maybe. Can I break points in here? I don't think I can. I don't think we believe in breakpoints. Let's see if there's a It's not there. Yeah, there's no break. Breakpoint on... Oh. I can? How? Are you sure? Let's see here. Don't think I can. Floating tooltip says how? Ah, control click. Okay. I see. You mean the thing that I've been ignoring this whole time? That tooltip? So then I could simulate and break. Genius. Oh, you know what I can do? I can do 19 here. It does remember a breakpoint at test 3. Genius! Because I can control that comparison. The other one I can't, because... I guess I could. I would have to devote 2 lines to it, though. I would have to devote 2 lines to setting accumulator to my on time -1, and then data to my off time. No, I wouldn't have to set that one. But, yeah. I would have to create a new solution to mess around with that. The art of the bodge, right? It is a little bit hacky, for sure. But I mean, it had 2 control loops. That's reasonable, right? Well received by our partners. Cool. Working remotely. Yeah. She's been in traffic for over 24 hours. Oh dear. This future, I don't think I like it. XBus causes the microcontroller to block until data becomes available. This radio has a non-blocking XBus buffer. Interesting. Non-blocking buffer will immediately return a value of -999 when no data is currently available. Should make it easier. Okay. So, RX is a non-blocking XBus input connected to radio receiver. Buzzer is a simple output connected to an electromechanical buzzer. Okay. This one has to be cheap, right? It's gotta be. Do that a little nicer. There we go. When a data packet is received over the radio, read it and execute the corresponding command on the following table. 0 is power off, 1 is power on. This is a blast and bringing back memories of years ago when I played this game myself and promptly forgot it all. Right? It's going to that bit, getting to that time when I usually fall unconscious. I prefer to do that over something soft like a bed. Pfft, easy mode over there. Okay, so it goes into a... I see. Okay. So what we need to do is we need to say... it's x0. So if you're greater than 0, I paid good money for my bed. I need to get return on investment. Right on, man. You have a great night. We'll catch you some other time. I want to continue playing this game. I want to get through this one on stream, and then we'll do Exapunks since I bought them. It'll probably be a weekend thing. Well, my weekend, anyway. And then we'll do some coding during the week. See if we can't, you know, shake it up. All work and no play and all that. Okay, so... if you're not greater than -1... well, if you are... then we need to say... what is the... its value is 1. Does this consume that? I wonder if it consumes that. What I could do, could move you into an accumulator. And then I can say, well, that gets chonky. This is what we're going to do. If x0 is -999, we're going to jump to the end. That's what we're going to do. Otherwise, we're going to have active here. Active I might not have enough code space in this guy. Because I gotta make it buzz. Oh, actually, you know what? I don't have to do that way. It's still gonna read it. 1. That's still asleep. Jump to active, otherwise jump to end. And then once we're inactive, ooh, there still might not be enough space though. it's not. I need the bigger dog. That for the sake of more code. There we go. Okay. If you're equal to 1, we'll call you, oops. We'll call you active again. That should be muted. And then we'll do that again. That. Here. Yep, OV. Sleep for 1. That's, oh no, not a P. 0 to P1. Sleep for 1. Test if ooh, this might be bad depending on how often this emits things. We'll see. If it's equal to 0, go to end. Otherwise, actually, if it's not equal to 0, just jump back to active. Nice. Look at that. Somebody managed to do it in one of the smaller boys. I bet you we could combine those loops a little bit instead of using the labels. Well, now I want to just to see. I'm going to create a new design. So we get a smaller guy in here. Boop. Boop. And we could say if it's equal to 1, all of that happens. Well, we would still need to do this, I think. If you're 0, I would need to be... Well, no, that... Because, yeah. I don't want to get trapped in the rabbit hole. I'm just gonna... Just throw that away. I want to finish the game. Okay. Where are we at here? My camera has gone blurry. Let me fix that really quick. Will it fall over? No, it won't. All right. Now, next. Actually, right now I'm going to take a really quick break and use the restroom. And I'll be right back, and then we'll do another. There we go. Meow. Where was I? I was over here reading this one. Custom LCDs, excellent. Retro style handheld games. Design and create an electronic game. Okay. If you finished all your assignments, I have more work for you. Nice. Okay. So this is where they start unlocking everything. Let's see, we got LEDs, we got LCDs. Huh, custom screens, okay. We've got one here. How do we use them? Have I overlooked them or am I blind? Okay. Let's see here again. Language reference. Parts datasheet. Microcontroller. Microcontroller. Digital I/O expander. Motor controller. Data packet reverser. Oh, that's RAM. ROM. Logic gates. Timekeeping. Comms. Sound blaster. Push button controller. Oh, here we go. This isn't quite... Okay, here we go. This is this guy. Except... Oh, okay. So how am I supposed to make a game? This guy just does, So we have to do... We'd have to create a custom deal to turn this on. It's just an LCD. It's an old school LCD. It's not a like an actual screen. It's like the ones with the lit up components, right? So with this guy, we can do... Okay, I'm coming up with an idea here. We have this guy. This plugs in here. No? What are you? T0. X bus values. Oh, duh, because I used the simple output. That's why. Derp. Yeah, T0 is the other thing. Okay, so here we can do this. And it just displays. Okay, right. Okay. Here's what we're going to do. We can do... We're going to do like a number guessing game, right? The question is, there's a push button controller. Is there any sort of a random non-blocking X bus pins? Okay. So we can do that. We probably need a bigger controller for this, but that's fine. What are you? 4ZB. We don't have any random. don't have random. Oh yeah, I was looking for this guy, the N4BZ, just because I'm curious what the heck it is. Comm solution, sound blaster. This thing that's all in Japanese, or Chinese, rather. This is NLP2, which is a different thing. This is 3 and 3. It's not that. Am I overlooking it? No, it's not documented. Okay, interesting. So how do we get our... This guy isn't documented either. This is the math guy, but he doesn't have random either. We could do... Do we have the clock? I don't think we have the clock. I don't have anything to set to generate a random number. Which is problematic. I also don't really have any... Hang on. Electronic gain. Well, it's not going to be a very good game, that's for sure. Look at these guys. What else could we make? Because we could do 3 of these, right? Can't seem to... How do I set you? Maybe we'll come back to this one. We'll have to think about that a little bit. Not sure. Like, will we unlock extra parts? All right, then. Let's see here. Little wireless controller. Okay. Okay, we have our little wireless guy. X and Y are simple inputs connected to a joystick. Okay. A and B are simple inputs connected to buttons. Radio RX is non-blocking X-bus input connected to a radio receiver. Radio TX is an X-bus output connected to a radio transmitter. Okay. When a data packet is received over the radio from the game console, respond with the following 3-value data packet, making sure you use the most recent input values. Zero if A and B equals 0. 1 if A is 100 and B is 0. Two if A is 0 and B is 100. And then 3 if A and B are 100. What about XY? We don't seem to care about XY. Okay. We can put you... and you... Nope, we don't care about those. Right? Free value data packet. Oh. They do want, okay, they do want X and Y. Okay, that makes a little bit more sense. I was like, why wouldn't they? Okay, so we're gonna need a chip for you because you, oops, you, and then you, and a bridge, and then a chip for you probably. And I don't know if we can get this all done in one or not. But you are that. I'm going to need more like that. And that. And that. And we'll do you to the RX. That's supposed to go over there. And then, oops. That. Except I can't get my, okay. We're gonna need a big dog. Because and I should be able to do I don't know if back and forth on the same one is gonna suck or not. We'll find out. You can be wired in there. This will need to go. Ooh, I can't do that really. Oh, I can move you down though. So that I have wait, you're not supposed to go there anyway. Hang on, what am I doing? You can go there. That doesn't make sense. Well, I can do this. Like so. I suppose that works, hopefully. Oh, but then I don't need this. Perfect. So we need like a labeled guy here, right? So when just call you wait, and I wouldn't even need to do this. So when we get a -1, then we send 3 data packets. X2, -1. If it's not, sleep, and go back to wait. Otherwise, what we'll do is we'll say this also needs to be And then these guys are both going to be responsible for x0 to x2. Oops. X1 to x2. But first, I need to send the x and then the y. Ooh. Okay, so what I need to do, x0 to x2, x0 to x2, and then x1 to x2. Because this guy, so here we're going to do the same thing. If this is a 1, if it's not, sleep 1, jump to wait. Otherwise, x, x0, x0. Let's test our thinking there first before we do the other one. He can sleep. Well, actually, we need to do his wait loop at least. If you're 1, if you're not 1, rather, sleep, jump to wait. Otherwise, just sleep. That way it'll continue to consume. Okay, so. Here's our first packet that we should have. It is negative, so we go fire off our request, fire off our... Ooh, I need to do that first. Okay. So this has to come in here. And then I can say, okay, give me your Y. Because I'm all out of X inputs on this guy. Okay, so there's our 1. We say, tell me about you. So it fires off that. We send 63. Oh, he's still waiting now. Crap. Oh, you know what? Duh. I don't need this. I can sleep until there, and then just do that. And then I don't need to do this either. Forgot about that. You're also an X0. Got extra bits and pieces hanging out here. I don't need you. There. Okay. Move 1. Block down right, block down right. Oh, I see. Crap. I can't do that because they block one another. Even though this Wait. Move one, and then it gets the signal. Yeah, it's blocked. Because one is still in there. Okay. I feel like I need more data ports here. Could I... Well, I got 4 simple inputs. That only allows for 2. I could combine some of this. What if I chucked you back in the bin? Get that out. Could put you down here a little bit. Yeah, I know you're not connected. Just clear all this out. Oop. Not what I wanted. There we go. Because this guy has a way simpler job. We probably still need to do, though, something like this to alleviate our congestion. That can go here. That got crazy. That can go there. And that frees up 2 here and the ones we need here. Makes my routing kind of messy though. Hang on a second. Okay. We need to do... That's still there. That's still there. We route this over here. Actually, we could probably do both of those guys up high. Maybe move this over one. We'll go to X1. We'll go to X0. You can come here. That's still going to need to jump higher up. We can do that. Could do that. Except this has to come up here still. We would need could we do that and then that can't live there. That kind of has to be like that. That kind of has to be like that. Put you here, I suppose. And then I can't really do that either. That needs to go here. This needs to go there. Can't do that. That won't really get me where I need to be. Could I, by chance, move you down one? And then that goes there. This goes here. Can't really do that either. This guy has to come here. Ah, here we go. Oops. That there. This here, that there. That here, that there. Okay, perfect. Now. You sleep until then, and then you send me actually for now, I'm just gonna move one, X1. This won't be the correct signal. That's fine. We just want to prove this out. That if it is -1, or if it's not, rather, oops, sleep and wait. If it is equal to -1, then here's what we do. We move P0, X1, move P1, X1, because that's X and then Y. We move 1 to X2, and then we move x3 to x0. How do we like that? We wait. Ooh. Do I flip my order of operations again? It's entirely possible. Thought equal. A is equal to B. Positive instructions are enabled. Not equal to B. Negative instructions are enabled. So, you're nothing. We get a 999. Okay, this one is the -1. So we send our 63. We send our 37. We send that. Why isn't it moving? I think we need to sleep for one here. Oh. Is it here that I need to sleep? What's going on? Why this? That should go to X3, but it's not. Interesting. Blocked on right, blocked on right. Do I have to consume that instruction? Oh, I do. Interesting, okay. That needs to go to X1, not X0. And then we wait. Okay. Aside from our dealio there. Now, is there a better way? We could actually do the same thing here then, if you have to consume it. For the sake of using less power. I don't think it really matters though, because it's sending 999s. So it's kind of pointless to have. Interesting. Okay. It's just an extra line of code. It's fine. So here's what we need to do is we need to do our logic here. It's not a 0, we jump to wait. Here we can say, we can do a new line. P0 and P1. If they are hang on. What I need to do here if you're equal to 0, I'm not gonna have enough lines to do this, I think. Yeah, I won't have enough lines for the test cases. That's going to complicate things a bit. I would need to probably use a big guy. Because if A is 0, it's either... If A is 0, we need to check B. If it's 100, we need to return 2. If not, we return 0. Yeah. Put these up here for a second. All right. I shouldn't need those X's over there. I'll need this one, and I'll need that one. So you can go away. So we can still do X 1 for this one as well. Can I just do that? No. can't really do anything about that. I'll just have to say not one we jump, which won't actually happen. It's fine. Then we come down to here. If you are where we say if A is 0, not A, P0 is 0, P1, 100. If you are, we move 2 to x0. Otherwise, we move 0, x0. Maybe I do have to do the negative first here. So if it's not 0, how do I want to do this? Oh, you know what I think I need to do here? Here we go. We can compare P0 and P1. If A is greater than B, then we can move. So that means it's literally P0 is A. So A is greater than B. We move 1 to x0. Right? Yes. Otherwise, which is the case for B, we move 2 to x0. If neither of these are the case, if A is greater than B, we move 3 to x0, because that means, oh wait, no. Okay, so we know these are equivalent if we're here. So if P0 is greater than 0, then we know we we move 3. Otherwise, we move 0. Like so. Uh-oh. Didn't work. X2. We waited for, because I did the wrong one. Oh, we're blocked on the right. Got to here. Let's actually break right before that guy. Okay. We get our -1. We send you. We send you. We tell you, hey, tell me about yourself. P0, P1. They're not equal. Oh, but that... Okay, yeah, that's correct. Well, you read, though. Why did you... That was consumed. We send our 2. Then gets sent. Oh, okay. Wait, why did you get... Why do you hang there? So that means B is greater than A. So B is 100 and A is 0. Wait. Because we're sending twice. So in this case, B is 100, A is 0, so it should be sending 2. Oh, because... here... we'd have to jump in both cases. There. All right. Okay. Buddy bots. It's pretty funny. Okay. DX300, they say. Which does what exactly? DX300, Digital I/O Expander. Okay. Read or write up to 3 on-off signals at once over Simple I/O or XBus. Ah, so we can flip its direction. Okay, perfect. We do want simples this direction. Input mode or output mode, writing an XBus value to DX300 will put its simple I/O pins into output mode. Specified output values reading an XBus value from the DX300 will put its pins into input mode. Okay. And it basically makes this into a XBus value with the digits turn. It's just bits, essentially. So hit, respawn, and alive. So we're going to write to this guy, I think. I guess I should read the rest of the challenge here. Hit is a simple input connected to an array of laser sensors on a vest. Okay. Respawn is a simple input connected to a quick connect jack on a vest. Alive is a simple output connected to an array of LED lights on the vest. Okay. Trigger and reload are simple inputs connected to switches on a replica gun. In a replica gun. Fire is a simple output connected to a laser and effects module in the replica gun. When a player is hit, their vest should be set to not alive. When a player is respawned, their vest should be set to alive. Okay. When a player reloads their gun, whether alive or not, their ammo count should be set to the ammo reload value, which I assume is this guy. When a player is alive, pulls the trigger, and has ammo remaining, the gun should fire and the ammo count should be decremented by 1. For realistic operation of various replica guns, the ammo reload value is set by the operator using a dial. Yes, that can be read as an XBus input. Oh, I can read you as XBus. Okay. Oh, yeah. Wait, no, we didn't do that before. We read it as a simple input, didn't we? Either way. Either way. Okay. Let's do like an ammo controller type of thing, I guess. And I don't know how you fit into this puzzle yet. We got lots of things happening though. Let's see here. The Hit just toggles our dead or alive state. Drag this out of here for a second. I think actually that this output's steady until something changes, which is interesting, if true. Yes, simple I/O pins on or off. Okay, cool. So that's how that can be used. And I might be able to get away with just one of these, actually. Well, no, we won't. We probably do need an ammo controller. What triggers a respawn? Simple input. Oh, no, I can't do this. Respawn is an input. It is an input. So we need to know if we're alive or not. That's going to be important. We need to know our ammo. Let's do that. When they reload their gun, whether they're alive or not, a reload is very simple. We do this. Yeah, hang on. Hit just basically says that we're no longer alive. So here we flip you. We need two of these guys. actually probably get away with this, right? So on a hit, we get that. Respawns a simple input connected to a quick connect jack on the vest. So when we're alive, we just need to be sending a signal there. So this is 001 on that bus. And I believe see here. Respawn just sends a signal periodically. Yeah. So here well, actually, we might be able to get away with simplifying this a lot. Come to think of it, if we wire this all up, because it has input and output modes. So we can sleep until we get an input. And then if this is 100, then we move, so that indicates a hit. Actually, we don't even have to do that. This is 010. B2. That should be 100 actually. I think. Yes. And then, did I do this incorrectly? Hang on. We're assuming that we start... No, we don't start alive. We start dead. So we sleep until we get something here. Yeah, 010. If it is that, then we move 100. Because it's backwards to X0. And then we sleep again. Otherwise, we just leave it, I think. Might be able to get through this with a couple little guys. We need to know if we're alive or not. We can have this signal here. And we can put this guy here. When they reload their gun, whether they're alive or not, ammo count should be set to ammo count value. Ending our verification. That doesn't go there. That goes there. We say we're going to wait until there's some kind of signal here. If the signal is $100, we check if we're alive. If we are, then we fire. Otherwise, we keep on going here. If the signal is 010, move X0 to the accumulator. And also when we're in here, we also need to check that. Otherwise, if it's a reload, we move X0 to ACK. Is that everything? Let's find out. Oh, I totally forgot to sleep. Oh, these guys emit constant signal? Good to know. Good to know. Okay. So our trigger was set. Nothing happened. Correct. Our respawn is going to get set here. And we're going to move that there. And now we are live. Oh, that doesn't stay. I see. Okay. We have to keep sending. Interesting. Okay. I think we can get this done with one of these guys instead. We still need these little guys. The Watchmedelios. Let's try this. X1 is that. P1 is that. X0 is that. X3 is that. P0 is that. Okay. And let me just double check here. So We basically need to know our state in here, I think. If this is 1 0 0, no, 0 1 0, that we'll use data as our aliveness. If the x3 is 0 1 0, I forgot to do that. That's important. Move x0 to ac, and then see here, we don't have our aliveness yet. Oh, we do. This is our loop. So sleep 1. Data needs to go, that's our aliveness, that goes to x1 at the end of all this. And then we also need to say if x3 is 0 0, nope, 1 0 0, then data better be 100. If it is, we just need to send a pulse for fire. P1. We can reset that to 0 at the end of our sleep. We could actually do it up here too. It doesn't matter. Well, if we're gonna do that, if I don't do this, I think it stays on a hundo forever. Let's just test that theory. To P1, and we also need to subtract 1. We also need to say that. And then if, oh no, we already did a reload logic, I think. So our trigger should happen here. It does. We say nothing about that because we're still dead. Nothing happens. Here, respawn gets fired. So we are alive. Oh, that fires back in. I see. Fire did not get set forever. Okay. We're still alive. Fire didn't work right there. Roll that back. We're alive. AC is greater than 0. Oh. Flip that. There you go. Pew pew. And we say that we're still alive. Okay, so that does get set forever. Okay. So, if we're going to do that, we should take this out of here. We're going to control our state in a different way here. This guy can come up in here. I'm just going to chuck that. This can come up here. This can get wired into a data. This can get wired into that. So, here's what we're going to do. We're going to say X1 if you are $100 move 100 P0. Okay, perfect. Otherwise, if you are 010 move 0 P0. That's our live dead. Easy peasy. The other one, X3 don't know if checking the pin is going to consume it. I hope not. If you're 100, right? No. Yes. If you're 100, if AC is greater than 0, then we move 001 to X3. Otherwise, if it is... Oh, we also need to say... Oops. If you're alive. Otherwise, if it is 010, move X0 to AC. Oop, forgot to sleep. Okay, so here comes our respawn input. We get a hundo on there. We say we are alive now. Trigger input comes in. It should be 100. It's not. Instead, we said that we were dead. What happened there? Respawn happened. It's 100. We move you. You're not that. Life is Gucci. Still alive. E0 is a hundo. That does consume it. Okay, so we can't do that. We need to do that. That. And then, oop, we can't use Ack. We'll use that. And that'll be that. And then in here, 0 to dat. So, go back to our fire. P0. Oops, I messed that up. This is Ack. This is dat. There we go. Okay. In comes the trigger. We are alive. This is greater than... No, that's not greater than 0. We sleep. Okay. Now reload comes in. And we reload. Perfect. And now fire will come in, or trigger will come in again. This is 1. That's 0. We move you. We send fire. Fire didn't get sent. Why did fire not get sent? Did get sent. It didn't get sent for... Okay. It didn't get sent for a full second. Or for a full time unit. Well, crap. That's still good. This. Move 100. P1. And then... after our sleep, move 0 to P1. Okay, what happened over here? Trigger gets pulled. We're alive. We have ammo. Move 100. We didn't reload. It did work. Oh, we get an extra fire in there somehow. That's what happened. So, whoop, we come here. 0 to P1. Well, trigger got pulled, though. Oh, you know what it is? Crap. We didn't do math. Could we still do... We need that. We need that. We could get rid of this because it's doubled. And instead, before we sleep, do that. That gets us 1. Now, that. Oop, no, I messed up something. I believe it needs to be up sooner is the prob. After we decided what that. Oh, actually, I wonder if that clears that. Our respawn gets set. Oh, because we did that wrong. That's why. Duh. Okay, so now fire is just the only one broken. So we do that, figure out what we want here. Trigger was pulled. That. Oh, that's just sub 1. There we go. Perfect. All right. Think that's what we're going to call it for today. So, thanks for everybody who hung out with me today. It was good to see you all. We will actually, you know what we're going to do? That's a lie. I'm gonna do one more game of solitaire, one more win of solitaire before we sign out. Unless it becomes obnoxious to win. Oh, that's a nice gift. Let's see, what else can we can free you up there. Can't do that. We could do that. We can do that. Guess I could do that. Gets me one out of there. Gets me that. That can go here. I can... I can't do that. Oh yeah, I can. I can swap that and that. Get that out. I can do this, and then... Oh, crap, no. Yeah, that back in there. Those up there. Might be kind of hosed here, though. I can move you here. I can pull you down. You give me room. You, then I can get you here to get some room. Where's my red one? You're under there. Do this, and then I do this. That goes up there, that goes up there, that goes here. These go here. Lots of room now. Here, here. There. Perfect. First try. Love it. All right. So now I'll call it a day. So thank you for everybody who came and hang out with me, came to hang out with me, whatever it is. Normally, I stream about 4 hours a day for 2 hours a night or so, starting at 8 p.m. Central Time. And I normally write real code. So if you enjoyed this, come hang out again. We'll just look at some other stuff. Like I was saying earlier, I want to try to play through Shenzhen I because I haven't beat it. In fact, we're now further than I've been, I'm pretty sure. I'll have to keep thinking about what kind of game we could really build with the pieces they give us. But, you know, maybe we'll circle back to that at the end. And with the wisdom of other things. But yeah. So come hang out again. And if not, you guys have a great week anyway. We'll catch you some other time. And thanks.